So we're continuing to simplify radicals, but in this topic we're going to talk about simplifying radical expressions that have variables and exponents in them. Now, for the most part, this process is exactly the same. You're going to factor whatever's underneath the radical, you're going to pull out groups of identical factors as a single factor, and that's it. Okay, that's the strategy. There's a little technicality that we run into with variables that for the most part we can ignore, but I will talk about it in a minute. Let's go ahead and look at this first baby example to make sure we understand at least what I'm talking about. So let's try to simplify the square root of x to the 6th power. Now this is the technicality that I mentioned. We say assume x represents a positive number. Okay, so in the next remark I'll go ahead and explain why this is important, but for now let's just focus on the square root of x to the 6th. How can we simplify that? Right, well, let's jump down here and I can explain what happens. To simplify the square root of x to the 6th, you first factor x to the 6th into 6 x's. That's what x to the 6th means. It means x times x times x times x times x times x. And then because we're dealing with a square root, we look for groups of identical factors of size 2. So every 2 x's comes out of the radical as a single x. And since there's 3 groups of 2, we get 3 x's being multiplied on the outside. Okay, now that takes care of everything underneath the radical, so all that's remaining would be the invisible 1 that was under there to start with, and we know the square root of 1 is just 1, so we're not even going to write it. Which means that overall, this radical simplifies to x times x times x, or x cubed. All right, so that's what we're going to be doing in this topic. All right, but I need to take a minute and explain why this assume x represents a positive number is important. The instructions in the last mini example that say assume x represents a positive number actually come from a very subtle idea involving radicals and variables. To help describe this idea, let me take away the variables for a moment. Let's just consider simplifying the square root of negative 51 squared. So first, you should have in mind when you see this something like the square root of x squared. Okay, where instead of x in this case, I have negative 51. If I want to simplify the square root of negative 51 squared, I could actually square the negative 51, okay, which means I get a negative times a negative underneath the square root here, which I could turn to a positive, at which point I have the square root of positive 51 times positive 51. And we know that the square root turns pairs of factors into a single factor. So you see here, even though I started with this negative 51 inside the parentheses, I ended up at a positive 51. Now this shouldn't really surprise you because we know that the square root, the principal square root, always outputs positive numbers. So the principal square root is always going to evaluate to a positive number. Whether you start with a negative number inside here or not, if you square that negative number and then take the principal square root, you will get a positive number. So when you simplify the square root of x squared, the formula or the rule is that you should get out the absolute value of x. Okay, the idea is no matter what x is, whether it's negative 51 or 17,000, in the end you have to have a positive result. So this absolute value operation is making sure that you get a positive result. Now, if x just so happens to represent a positive number already, then the absolute values are meaningless because x is already positive. So if x represents a positive number, then the square root of x squared is exactly what you think it should be, regular old x. Since x is already positive, this is perfectly legit. For the most part, this subtlety in the square root operation, in the principal square root operation, is not going to make a difference. Okay, but I want you to be aware that in all technicality, if you take the square root of x squared, you should get the absolute value of x, because you have to make sure that your square root ends up with a positive number. All right, let's move on to some more concrete ideas. The main idea for this topic talks about simplifying the nth root of x to the m. So for example, we want to be able to simplify things like the cube root of x to the 7th. Okay? The first step in this process is to break the x to the m into groups of n. So for example, in the cube root of x to the 7th, the first step would be to break the x to the 7th into groups of 3. So 1, 2, 3, 1, 2, 3, and then 1 extra to get me to 7 x's altogether. So step 1, break the x to the m into groups of n, just like this. Step 2, for each group of n, pull out a factor of x from the radical. So because my n is 3 in this example, I'm going to look for groups of 3. And each group of 3 in this case is going to bring me an x factor outside of the radical. So in this case, the cube root of x to the 7th will actually be equal to an x and an x being multiplied outside the radical, and then still a single x left inside the radical. So altogether we have x squared, cube root of x. Remember, these two factors, these are connected by multiplication. Okay. So step 1, break your x to the m into groups of n. Step 2, for each group of n, pull a factor of x out of the radical. Okay. And then anything that's left inside, put back inside. The results should be connected by multiplication. The main idea for this topic only talks about simplifying variables underneath radicals. Okay. But we're going to need to simplify not only variables, but also variables and coefficients underneath radicals. So the moral of the story here is if you have a coefficient attached to your variable, you simplify the coefficient separately from the variable and just multiply your results. So for example, if you want to simplify the cube root of 24x to the 5th, first you would factor 24 down using a factor tree. Right? 24 is 2 times 2 times 2 times 3. Then you would factor the x to the 5th down. X times x times x times x times x. Then you go in and circle your groups of 3, right? Because our n is 3, we're going to be looking for groups of 3. Here's one group of 3. Here's another group of 3. So a single representative will come out, which means we have a 2x on the outside. And then we still have a 3 and an x and another x left on the inside. So on the inside of our cube root, we have 3x squared. So it's not super complicated to add an extra coefficient in there. You just have to do a little more work by factoring that coefficient and circling your groups of n. All right, let's get to the examples and see if we can put this all together.